Today's lecture will cover Alice Chapter 2. First, I will go over tutorials 2B and 2C, in case you're having any trouble with them. And then I will go over some slides about exactly what parameters, variables, and properties are. Now, those slides aren't covered in the homework, but I think it's important that you go through them with me because they form the basis of Chapter 4. But we'll get to that after the tutorials. If you've already done the tutorials, and you're sure you've done them right, you can skip over this part and just skip to the part of the video where you start seeing slides. So let's get started. Tutorial 2B. In Tutorial 2B, we put the Cheshire Cat, Alice Little, who's the girl in Alice in Wonderland, and the White Rabbit from Alice in Wonderland, all on a grass plain, and then we're going to have them jump. And your homework goes off of the world that you've created in Tutorial 2C. So first, let's add the objects. We've done this before. Should be pretty easy. First, let's get the Cheshire Cat. Here he is. Add the Cheshire Cat to the world. Let's move him over here. And now let's get Alice. She's not an animal, so she's going to be in people. And there she is. Move Alice over to the center. And finally, we're going to get the White Rabbit. And the White Rabbit is an animal. It's probably in here. And there it is. White Rabbit. Move the White Rabbit over here. So, now we're going to all make them turn to face the camera because we want them all facing the camera. So to do that, we right-click the object, and this is called a one-off method. So we're going to execute a method that you can execute in the world, but we're just going to execute it before the world's begun, and we're only going to execute it once. So turn to face camera, Alice, turn to face camera, White Rabbit, turn to face camera. So now they're all facing the camera. I'm going to move Alice over just a tiny bit to make her closer to the center. So we've got that set up. So now we're going to design a method called the triple jump method. And if you look at page 49, it talks about an organizational chart for the method. It goes into all the exact commands you're going to need. And so basically we're going to have world.myFirstMethod be the triple jump method. It's going to make all three of them jump. But instead of putting everything in world.myFirstMethod, like put White Rabbit move up, White Rabbit move down, Alice move up, Alice move down, Cheshire Cat move up, Cheshire Cat move down, and I switched the order of the Cheshire Cat and Alice there, sorry. We're going to create a method for each of them to jump. So we're going to write four methods for this program. We're going to write world.myFirstMethod, which makes all of them jump. and then we're going to write 3 methods, each making one of them jump. So in Alice, before you can call a method, like in Alice, to do anything, you drag tiles into this editor, if you remember from chapter 1. So we would, make the white rabbit move up. So before we can write world.myFirst method, by the way, that's how you get rid of something, you drag it to the trash can up there. We're going to need to write the 3 methods that world.myFirst method is going to call. So we need to write white rabbit jump, Cheshire cat jump, Alice jump. Because only after we've written those can we drag them over into world.myFirst method. It's like the program literally won't let us call a method that doesn't exist. Alice will not let us do that. So let's start with white rabbit jump. These are going to be very simple methods. So white rabbit, we've highlighted white rabbit here in the object tree. If white rabbit isn't highlighted, go ahead and highlight them. Now we're going to click create new method. And we're going to call it jump. So now we have white rabbit jump, and it automatically opened in the editor. So to do that, the white rabbit is going to first move up 1 meter. I'm on page 52 now. And then he's going to move back down, because if you jump up and you don't come back down, that's not really jumping, that's more hovering. Cheshire, so now same thing with Cheshire cat jump. Tab opens here. Cheshire cat move up 1 meter. Cheshire cat move down 1 meter. And finally, Alice. Now there are some methods already written for Alice. I didn't write these. They come with the Alice program. They're not exactly like these because you can edit them. As you can see, they can be a little bit complicated. We're not going to go into these. You don't need to know anything about these. These are just some methods that the Alice programmers wrote for us. But unlike these, they're not written below the level of Alice programming. They're written as Alice methods, so we can modify them if we want to, but we're not going to want to, and we're not going to use these. So just basically don't let these confuse you. So Alice create new method, jump. We're now in the Alice little jump editor. Alice move up 1 meter. Alice move down 1 meter. And so now let's play the program and see what happens. I'm doing this to make a point. So if you know what's going to happen, go ahead and guess, and then I'll do it. Okay, I'm going to run it now. They do nothing. Why do they do nothing? Well, we wrote all of these methods, and I'm going to close them now because we've written them and we don't need to have them open anymore. But the only thing that the Alice program is going to run is world.myFirst method. And world.myFirst method has no code in it. So world.myFirst method does nothing. So our world does nothing. They just stand there. They don't jump. We wrote methods so that they can jump, but we didn't call them. So now let's go ahead and call them. We're going to first make the white rabbit jump, then the Cheshire cat, and then Alice. So to get to white rabbit's methods, we click white rabbit in the object tree. We see a tab for the jump method that we wrote, and we drag it here. Now the white rabbit's going to jump. Go to Cheshire Cat, get its jump method, drag it in here. Now the Cheshire Cat's going to jump. Finally, Alice. So now, if you look at figure 217 on page 53, we've written it, and they're all going to jump. So that's pretty good. They've all jumped. That's what we wanted to happen. So let's go on to tutorial 2C. Tutorial 2C talks about making parameters. And so read the introduction on page 54. And now we're on 55. So what you're supposed to do now is you're supposed to save this world as triple jump. So that when we modify it, we don't do anything that messes up the original Alice world. So we still have the world from tutorial 2B, and you can start from it if you ever need to. If you ever need to start over, you can start from there instead of starting from the very beginning and having to do tutorial 2B again. So we can now open triple jump here, and we've got our world back. And now we're going to go ahead and create a parameter. So you've got the white rabbit here, white rabbit jump method, and we don't drag it anywhere. We click the edit button and open it up here. Then to create a parameter, this is fairly intuitive. You click the create new parameter button, and the type of the parameter is going to be a number, because this is how high to jump. The parameter we're going to put for the jump method is how high the object should jump. So let's call the parameter height, because that's what it represents. Now we've got our height parameter, and we're not finished yet. One thing a lot of students will do in this part of the class is, okay, I put the height parameter in, now I'm going to go ahead and play the world. And right now this looks right, but it's not, because if we change the height to 2, the white rabbit still only jumps to a height of 1. Now think about why that might be. Think about what we did wrong here, why height is not controlling the height of the white rabbit. See if you can guess, and see if you can guess what we need to do to fix it. Now you can just turn the page and look on page well, you can look at figure 220 and it'll tell you what to do. But think about it, because this is an important concept. Alright, so the reason the white rabbit is still only jumping 1 meter is because even though we created this height parameter, we didn't use it anywhere. For the height parameter to be used, we need to program in the locations where height should be used. So right now the white rabbit jump method is move up 1 meter, move down 1 meter. We've still hard-coded in 1 meter here. So what we need to do is we need to replace that with height meters. And now it looks a lot better. Because the white rabbit jumps the height that we give it. So now he jumped half the height of the other ones. Now, why can't we change the height of the Cheshire Cat or Alice Little when they jump? Well, because their methods need to have a height parameter too, and you need to do basically the exact same thing we did with the Cheshire Cat and Alice Little. And that's your homework, so I'm not going to go into it. But now that you've seen how to do it with a white rabbit, it should be pretty easy to mimic that for the Cheshire Cat and for Alice. So, we're going to be done with Alice for now. Oh, we changed the world, so we should save it, and we should give it a new name. The name it wants us to give it is triple jump with parameters. And now we're going to get out of Alice for now. And my computer's working a little too hard for some reason, so ignore that. That was just to fix a little problem I'm having here. Alright. So now the slides. So even if you've done the tutorials yourself, you should watch this part. I'm going to talk a little bit about what parameters are and what variables are and what properties are. These are important concepts. They're the base of algorithms. These constructs hold values that can change during the execution of a program. They all have types, which is the kind of data a variable can hold. So in Alice, in our triple jump with parameters method, I'm going to use it as an example here. The white rabbit jump method takes a parameter. The parameter is called height. The type of height is number. If you see it says 1, 2, 3 here, that means it's a number. Whenever we create a new parameter, we select its type. String here, that's a type. Sound is a type. So Alice has a lot of types. This also has to do with the type, but we're not going to get that until chapter 8. So don't worry about this for now. Don't ever check this. So our height parameter here is a number, so we can use it wherever the method needs a number. Wherever we need to give the white rabbit jump method a number, we can put height in. And we did that earlier. We dragged height and we put it here. This used to say 1 meter, now it says height meters. The type can't change during execution. Once you create a parameter or a variable or a property of a certain type, it's going to stay that type forever throughout its entire life. You can change the value of one of these things during execution. But first let's talk about how they differ. Parameters are created at the start of a method call and destroyed at the end. So this height parameter right here, it's created at the start of the method. World.myFirstMethod calls whiteRabbitJump with a value for height. That value for height is substituted in here, and then it uses that value for height. And then once this method is finished, it's destroyed. So if we called it again and gave it a different value for height, it would use 0.5 for height here, 1 for height here. So this is pretty easy to understand. Variables are the same as parameters, but they are created at the start of a method and destroyed at the end. But the initial value isn't set by the caller of the method. For a variable, the initial value, I'm going to create another number, dummy variable, because we're not using it, world.myFirstMethod. With a variable, the original value is set by whoever's programming the method. So every time world.myFirstMethod starts, dummy is going to be initialized to the number 2.3. Now we don't need this, so I'm going to drag it to the trash. And now world.myFirstMethod has new variables. Once again, properties have a different lifetime. Properties are set at the start of the world and they're never destroyed. So if we create a property of the world called make jump, and I'm creating a boolean here. Make jump is initialized to true or false at the start of the world, and it's never destroyed. So as long as the world is running, the property make jump can be accessed by any method running in the world. It can be changed by any method running in the world, and it's never destroyed until the world stops executing. And so that's what this slide is about. Who sets the initial value of these? Now, can these things change? Yes, definitely. Any one of these things can change. You can change the value of a parameter, a variable, or a property. And to do that, all you have to do is drag at the tile representing the variable, property, or parameter you want to change. Put it in here, and then put a set value command here. So now, at the end of the world, at the end of world.myFirstMethod, the world.makeJump parameter is set to false. And later, you might want to look at this lecture again, because later we're going to have variables that change frequently. And all you have to do to understand that is to step through the method step by step. Okay, first it's going to do this, then it's going to do this, then it's going to do this, then it's going to do this. Just go one tile at a time, one line at a time. And you'll be able to understand how this world is executing. So that's what this slide is about. To execute an Alice program, you go step by step, line by line. And whenever you reach a call to a method, you suspend execution at that line, and the method is called. Meaning you start over executing step by step, line by line, in that method. When that method finishes, you go back to the caller and go to the next line after that. Now, how deep can you go with this? How many methods can you have executing at a single time? Well, there's really no limit. And a method can even call itself, but we're not going to get into that. There's no limit, but conceptually, there's no limit to the number of methods that can be suspended waiting for a callee to return. Programs are hierarchical like that. So if you want to if you want to step through this program line by line to understand how it's going to execute, first you look at the first method that's called here. whiterabbit.jump height equals 0.5. Now, is this a user-defined method or an Alice-defined method? If it's an Alice-defined method, then we can't look inside of it to see what it does internally. But in this case, it's a user-defined method, so we can. So you open up the whiterabbit.jump method, and we look at this line. Okay, whiterabbit is going to move up height meters. All right, what is height? Height's a parameter. So we look back, okay, height is 0.5. So the whiterabbit's going to move up half a meter, and then the white rabbit is going to move down height meters. Okay, so we already know that height is 0.5 here. So it's going to move back down half a meter, and now it's going to be back on the ground. And now this method finishes executing. There aren't any more commands in here, so we go back to world.myFirst method to the next line. Next line is Cheshire Cat jump. Is that a user-defined method? Yes. So we go ahead, look at Cheshire Cat's method, and open up the jump method. Cheshire Cat move up 1 meter. Okay, so we're not using any parameters. It's always going to move up 1 meter. And that's an Alice-defined method, so we can't go any lower and look at how that method works. Cheshire Cat move down 1 meter. Okay, so it's going to come back down. Now we're done with this jump method because we have nothing left to execute. Alice Little jump. Okay, that's another user-defined method. Open it up. Alice Little move up 1 meter. Alice Little move down 1 meter. So same as Cheshire Cat. Alright, so that method's done. So now we go back here. Okay, we don't have any more stuff to execute here. So the program is finished. Now, just to make sure you understand how this is supposed to work, I'm going to drag the jump tile here, and I'm going to set it to 2 meters. So now White Rabbit's going to jump half a meter, Cheshire Cat and Alice Little jump, then the White Rabbit jumps 2 meters. So let's see how that works. So he jumps twice. Once he jumps half a meter, once he jumps 2 meters. And so the reason he jumps 2 meters is because the parameter is 2. So when we get to this method call, we say, okay, the White Rabbit jumps 2 meters, so I'm going to go in here. Okay, height is 2 meters. He moves up height meters. He moves down height meters. So he's going to jump 2 meters high. He's going to move up 2 meters, and then he's going to come back down. Now, I'd like to point out that in real software development, a large part of the reason we use methods, large part of the reason we don't just put all of the code into world.myFirst method, because we could, right? We could say, White Rabbit move up half a meter, down half a meter, Cheshire Cat move up a meter, down a meter, Alice Little move up a meter, down a meter, White Rabbit move up 2 meters, down 2 meters. We could just do all that. Put all of it in one method. The reason we don't is so that we don't have to think about how the computer is doing certain things. One programmer writes the code for a method that does something useful, like, say, searches a document for a certain string. Let's use that as an example. You might have a method that looks through a whole bunch of text and finds all of the locations of a name that you pass it. Like, okay, search all text for instances of the word Joe. Search all text for instances of the word coffee. Just anything like that, and it'll no matter what text you pass it, it'll search for that text. Well, that's useful. A lot of programs might be able to use that. And it's fairly complex to write. You don't want to write it yourself every single time. It's actually not that complicated, but let's assume that it is. Let's assume it's doing something complicated. You have one programmer write that, and then a whole bunch of programmers use it. And the idea is they don't open it up and look at exactly how it works, because they don't care. It saves you time. It's a time-saving mechanism and a way to limit the amount of complexity you have to think about. So once you've written a method and you're sure it's right, unless something is going wrong in your program that you think is related to that method, unless you think there's a mistake in that method, you don't bother looking at how it works exactly. Because that's the beauty of this. That's why this is useful. You don't have to look at this. You don't have to know how they're jumping. All you have to know is that this method makes them jump. So back to the slides. All right, last slide. To help you with your homework and to solidify these concepts, I'm going to go through an example. We're going to have a dancing bunny. We're going to have methods to make the bunny spin, jump, and move in a square. And we're going to take parameters for how many times to spin, how high to jump, and how big a square to move in. And we're going to start with completed functions with no parameters, and I'm going to add parameters. So let's get started with that. We're going to close this, start a new world. World's been modified. Would you like to save it? No. So before we do anything, we have to add our bunny. Should be very familiar with adding bunnies to worlds by now. So here's our bunny. Let's make him turn to face the camera. And now we're going to make a whole bunch of methods for the bunny. Now what did we say? Okay, we want to make him spin, jump, and move in a square. So let's create a bunny method named spin. Alright, we're editing spin. So in order to make the bunny spin, what should we do? Oh, we can make him turn. So we're going to make him spin once. And let's make him spin to the right. He's going to spin all the way around. Very nice. Now we're going to make him jump. Well, we just made him jump, so we know exactly how to write that method. So create new method, jump, and let's make him jump 1 meter. So move up a meter. Now move down a meter. Now, in case you haven't noticed, these are parameters here to the move method. We can't open up the move method because it's part of Alice. But this is a method that we're giving 2 parameters. Up 1 meter and down 1 meter. You could also think of bunny as a parameter too, but since move is a method of bunny, changing this would really be making it call a different method, sort of. But these definitely are parameters: what direction to move and how far to move. So built-in Alice methods can take parameters too. Just want to point that out. It's the last thing we want to do. Move in a square. Alright, that's a little more complicated, but it's not that bad. So first, let's make him turn first. Turn left 1/4 revolution. Then move forward 1 meter. Then turn again left 1/4 revolution. Move forward 1 meter. Turn left 1/4 revolution. Move forward, move forward 1 meter. Turn left 1/4 revolution. Move forward 1 meter. And now let's try this out. Make sure that he's doing all this stuff the way we wanted him to. I'm calling these methods. I'm putting calls in for these methods we just wrote into world.myFirstMethod so that the bunny will actually do this stuff. All right. So he's doing this right. But now we want to add parameters to these methods. So for the spin parameter, we're going to make a parameter for how many times to spin, and then how high to jump, and then how big a square to move in. So obviously we're going to create a new parameter here. What type should it be? Think about it. It should be a number. And bunny and the name we can call it times. And now how many times should the bunny spin? How do we make it so that this method uses that parameter? Well, just drag it here. He's going to turn right x revolutions, where x is the number of times, where x is this parameter. So this is like x, basically. You can think of a method like x. You can think of a parameter to a method like x in an algebraic expression. I'm going to do this x times. I'm going to jump x meters. You could even name the parameter x, but that is considered poor naming practice. You generally want to name a parameter or a variable something more creative than that, something that lets other programmers and yourself, when you look back and try to figure out how a method you wrote 6 months ago works. You want to choose a name that makes it easy to understand why a variable or a parameter exists, what it's doing. So times is a much better name than x. But that's essentially what we're doing. That's how the substitution process works. So now bunny jump. I'm not even going to talk about this because we just did this. Finally, bunny square. So we're going to need a parameter, and I'll give you a hint. We only need one parameter. So the parameter is going to be, let's say, length of square, or length of square line. So the length of one line in the square. So where do we put this? It's not going to be everywhere. Give you a hint on that. So pause this and see if you can figure out where I should drag this parameter to incorporate it into this method. Okay. Where I'm going to drag it is here, 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 and here. And not here, 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 or here. The reason not those places is because squares always have 90-degree edges in them. And the turning part is what makes the degree of the edge. 1/4 revolution is 90 degrees. And since we're always making a square, this is always going to be 90 degrees. The length of one side, and I'm going to rename this length of square side. That can change. If you how far he moves before turning determines the size of the square. And so that is where we substitute in the parameter. So let's go back to world.myFirst method, and we can make him spin 4 times, jump 3 meters, and move in a 5-meter square. And let's see what that does. Oh, he's off the screen. That's a shame. Now, if you notice, he seems to be going faster. And the reason for that is that unless you go to more here and select the duration, every one of these built-in Alice methods completes in 1 second. So I'm going to change this to 3 meters and see if that makes it better. Alright, so now he's just barely on the screen, so that's okay. So that is our bunny dance project. The goal of this was to let you see how some of these concepts work before you have to do them in the homework. I think that this chapter's homework is fairly easy, so hopefully won't be too bad, but as always, ask questions on IRC, or if you can't get me on IRC, over email. One thing about asking me questions on IRC, post questions to the CSCI 1000 channels. Don't private message me on IRC. I'm not sure how you're doing that, but in Pigeon, you open up the chat room and then type your question into the chat room. And you don't click on my name or anything, because then the message goes to me and no one else, and also I'm not checking my private messages, so I am probably going to miss it if you do that. So once again, just want to point out for later, parameters, variables, and properties have many similarities. They all have types. They're all things that you use to substitute for a value. So they're all like x, y, or z in algebra. And they can all change during execution. You can change the value of a parameter or a variable or a property. During execution, all you have to do is drag the tile into a method and then say set value to this. And you can do things like change it. You don't have to set it to a specific value. You can do things like increment it. Like say you wanted to, in this bunny jump method, you want them to jump however high, and then you want them to jump even higher, 1 meter higher than however he jumped before. Well, to do that, you would take height, set value to height, and then you would choose math here. Height plus, we want it to be 1 meter higher, so height set value to height plus 1. And then you would just let's see if I can. This is the clipboard. You can put things on the clipboard and then drag them off the clipboard. So might as well show you that here. And then you just do the same thing. And so even though these are the same commands, because height has changed, it's going to make him jump higher. So he's going to jump twice. First he's going to jump height meters, then he's going to jump 1 extra meter. So he's jumping 3 meters, then he's going to jump 4 meters. So let's watch this. Spin's the same. You can see he jumped higher before. And he went off the screen again. So let's bring that down to, let's say 2.5. And let's bring the height down to 2 so that we can actually see him when he jumps. Spin 4 times, jump 1 meter higher, and then make a square. So hopefully that illustrates for you how these things can change. And again, if you're confused, just step through it line by line. Move up height meters, move down height meters. Height set value to height plus 1. Okay, so we're changing the value of x. So now, even though this says x, it's going to be 1 more than it was before because we just changed the value of x to 1 more than it was before. So if this doesn't make sense, please ask me questions about it, because this is going to be very important later. Specifically, this is going to be very important in the algorithms part, and we're going to talk a little bit about it in chapter 3 too. So you don't really need to understand this for this chapter's homework, but it's going to be very important later. So make sure you understand how all of this works. You step through to see what a program's going to do. You step through it line by line. Bunny spin. Okay, how does the bunny spin? What does this mean? Okay, let's open up bunny spin. All right, there's a parameter here, so this is like x. Where's x used? X is used here. All right, so he's going to turn right x revolutions, where x is whatever we passed here. So he's going to turn right 4 times. Bunny jump with a height of 2. Okay, height's a parameter, so he's going to move up x meters, down x meters. Then we're going to change x so that it's equal to x plus 1. Now think about what I just said. That's a little bit different than math because x is never equal to x plus 1. But you can change x here. So now this parameter has changed. And so now we're going to move up height meters and down height meters but height is going to be 1 more than it was here. So height starts out as 2, so he's going to move up 2 meters, down 2 meters. All right, now height is 3. He's going to move up 3 meters, down 3 meters. Then Bunny square, where the length of a square side is 2.5. All right, so he's going to turn left 90 degrees. So because he's facing us, he's going to be facing our right. From our perspective, it's going to look like he's facing right. Think about how left and right work. This is right. This is true. Then he's going to move forward. Length of square side meters. All right. Length of square side's a parameter. What was the value of that parameter again? 2.5. All right. So he's going to move 2.5 meters. He's going to turn another 90 degrees. So now he's going to be facing opposite the camera. Move forward 2.5 meters again. Okay. Turn left 90 degrees again. Now he's going to be facing left. Move forward, length of square side meters. Move forward, move back 2.5 meters because he's facing away from us, so his forward is our back. Turn left another 90 degrees, or I'm sorry, he's going to be moving left here. He's going to be moving, because this is the third leg of the square, so he's going to be moving like that. Bunny turn left 0.25 revolutions. All right, so now he's facing us again. Move forward 2.5 meters. So he comes forward 2.5 meters. Back to this method. Okay, now what happens? All right, well, that's it. So this is how you step through a program. If your program's ever not working right, this is how you figure out why it's not working right. You step through it line by line and see where it's doing something other than what you want it to do. Basically, see where the mistake is by walking through it in your mind. And that's really the fundamental skill of programming, being able to step through a program like this. Well, it's a fundamental skill of programming. It's the fundamental skill of debugging, which is the process of correcting errors in a computer program. Being able to step through a program with your mind. Now, in Alice doesn't have this, but in professional programming languages, there are tools called debuggers, which can sort of step through a program for you. It shows stuff on the screen. It shows the values of all the variables and parameters and everything on the screen. Has a little arrow pointing to what line you're on. And then you click a button that says next, and it goes forward exactly 1 line. Those are just tools to make this easier to do. Alice doesn't have those. But that's okay, because you can still do it with your head. And Alice does have a debugging feature, which I'm going to show you now. The book officially goes over this later, but I want you to have access to this as soon as possible. Print. And then print the world. Okay, so that's not useful, so let me put it somewhere where we have actually have a parameter. So print, we're going to put print here. Make sure it's green. Print times. Alright, so it's going to print the number of times he's going to spin here. He's going to print the value of this parameter. Alright, so it prints 4.0 to the bottom of the screen, and I'm going to stop him, because that's the value of times right here. Bunny jump, print the value of height here, and then take this exact same statement, transpose it to here. Height's been incremented by 1, so height's going to be 1 more than it was before. Alright, so if you see it prints out 2.0, then it prints out 3.0, because the value of height changed between those two statements. So this printing out text to the screen is an extremely versatile debugging tool. So if you're ever running into problems, using this print statement is a good idea. And I'm going to be using it again in our examples for Chapter 4, Chapter 3, Chapter 4, and onward. So, that is all that I have for today. Good luck on the homework, and I will post Alice Lecture 3 early tomorrow morning. Goodbye.